Hi, everybody. Welcome to AB Calculus AB course. This is the first unit, limits and continuity. And this is the first lecture, 1.1. Can change occur at an instant? What does that mean? So far, you have learned how to find out the change happening between two different points. In your Algebra 1, Algebra 2, you know how to find out change between two different points. So if I have to draw a situation, let's say there was somebody who was at this point, and then after some time, they reached at this point. Okay, so these are two different points, and if we have to find out what is the change that has happened from this position to this position, and let's also say that there is this curve representing their position. Okay, and we know the x and y coordinates of these 2 points. Okay, let's say that this point is 1 2, this point is 4. Okay, and then let's say that the y coordinate, so this point is 1 comma 3, and let's say this point is 4 comma 5. Okay, so we're interested in finding out the change which has happened from this point to this point. Okay, so we connect these 2 points. We connect these 2 points with a straight line. Okay, and then we find out the slope of that line. Okay, and we also call this average rate of change. Average rate of change, which is simply the slope of this line. And the slope of this line, you know that the formula was y2 minus y1 over x2 minus x1, or the change in the y coordinates, okay, divided by the change in the x coordinates. Let's call that this function is f of x. Okay, so we also say that this is going to be f of 4 minus f of 1 over 4 minus 1. Okay, so f of 4 is 5, f of 1 is 3, and 4 minus 1 is 3. So 5 minus 3 is 2, 2 over 3. This is the average rate of change. Okay, so for every 3 units of change in the horizontal directions, there is a change of 2 units in the vertical direction. Now, in calculus, this is also the essence of calculus. We are interested in finding out the change at just one single point. Okay, at just one single point. So let's say that we are interested in finding out what is the change which is happening at this point. Okay, now that is called the instantaneous rate of change. Instantaneous rate of change, that just means that change which is happening at an instant. Instantaneous rate of change. Instantaneous rate of change. Now, we are interested in finding out what is the change which is happening at this instant. Okay, so one thing that comes to my mind is, how about I take one more point at exactly same location. Okay, at exactly same location. And let's just say that this is, I don't know, 2. Let's say this is 2. So I've taken 2 points at exactly x equals to 2. So if I try to find out the change, I'm going to get f of 2 minus f of 2 divided by 2 minus 2, right? Because I've taken 2 same points. So the f of 2 minus f of 2 will be 0, 2 minus 2 will be 0, and we are going to get 0 by 0, which is not 1. It is undefined. 0 by 0 is something which is undefined. It is not 1. Don't cancel out the zeros from top and bottom. Okay. So now then what do we do? Now, the next thing that comes to my mind is, what if I don't take this green point exactly on the red point? What if I take it very close to the red point? Okay. Okay. What if I take the green point very close? Okay, so first I'm going to take this green point here. I'll slowly bring it closer and closer to the red point. So if I take the green point here and I connect these 2 points, I'm going to get a line like this. Then I take the point further closer and then connect the 2 points. And still we have a secant. And now I'm going to take it so much close, very close. I'm going to take it really close to the red point. It is so close that this time it is going to appear that there is a tangent. There is a tangent which is just touching the curve at this point. Okay, the 2 points are very, very, very close. Okay, the 2 points are really close. Okay, so this will allow us to find out the instantaneous rate of change. Okay, this is the idea of limits. Okay, so the 2 points are very close, but still they're not exactly same. Okay, and we're trying to find out the average rate of change between these 2 points. Okay, but the second point is like really close to the first point. So this is the concept of limits. Now, I also want to take one more example to explain the concept of limits. So let's say that this is you and this is your friend. Okay, okay, like this. Yeah, and you want to reach to your friend. Okay, but you are only allowed to travel half of the distance which is between you and your friend. Okay, so right now, whatever is the distance, you can only travel half of the distance. You can never travel the complete distance. So the half of the distance, if you travel half of the distance, you will come here. Okay, then again you travel half of the distance between you and your friend, so you will come here. Then again you travel half of the distance, you will come here. Then again half of the distance here. Now my question is, will you ever reach your friend? This is a thought experiment. Think about it. Will you ever reach your friend in this way? The answer is no. You can never reach your friend because there will be always some distance between you and your friend. So let's say if this distance initially, if this distance was 1 meter, right? So when you travel half of it, then the distance is 1/2 of a meter. And when again you travel, then 1/4 of a meter. Then if you again cover half distance, then 1/8 of a meter. Then 1/16 of a meter. Then 1/32 of a meter. 1/64 of a meter. There will be some distance every time you move. It doesn't matter how small it will become, right? It will be just a very, very, very small fraction, right? But still there will be some distance. This is the idea of limits, and also some essence of calculus. Now it will seem like you're very close to reaching your friend, but still you're very far. I mean, this is a kind of a intuitive thinking, right? It will look like you're very close to your friend, but still there will be some teeny tiny distance between you and your friend. So I hope you got the idea of limits. And in the next coming lectures, we will see the notation, the definition, and some techniques to evaluate limits of functions.